Well, this morning I did a new print. Spacers on the back side. I figured out and fixed that spacing, I think. I made the holes a little bigger. This is only going to be a minute or two because I got to leave here any minute to go help my buddy Dave with his roof. Okay, well, I guess I need to drill them out again. Oh yeah. So either there's a slight discrepancy in the print dimension, or yeah, see, that one goes on, that one goes on. Okay, so that's a wee bit tight. Nice. Nice. Perfect. Okay. Since none of the rest of this changed, I don't think there's any reason for me to, certainly not at this time, to put the hub back on and put the caliper on. I will do that later, next time I have, you know, some time to mess with this, because I want to double check the height of the boss on the back side here. And, you know, these holes could be a little tighter today, even though I opened the dimension up in CAD, because I printed with a little bit extra wall and 20% infill to, you know, make it even a little bit more rigid. So if I want to put any boss on the front side of here, you know, to make this, I can make the whole thing almost 1/8 of an inch thicker. I could easily do 50, 60 thousandths, probably close to 100 thousandths. And then I could also make it thicker on the back side. I may make this thing, I'll probably make this 1/8 of an inch thicker on the back side, so I get rid of the bosses. I'll have to see. Once I get in there and start working on the design and that stuff, I'll play with it a little bit. But I should be able to just duplicate it just the way it is, except for these bosses here won't be machined in, and there won't be that little divot there, you know, as if this is a separate piece. That'll just stay in the aluminum. I would probably still go through and do tine inserts, and helicoils, that kind of thing, for these. If they were pass-through holes, I wouldn't worry about it, obviously, but they're not. So it's about 6:30 here, so there's not enough light outside yet to do this. So I have the Ryobi set up. So anyway, I did enlarge those. I haven't had to drill this. It looks like the holes are going to fit okay. They are really close tolerance, so I want to open it up a bit more for if it's done in steel or aluminum. But look at that. All right, no John Deere fit there. That's for my buddy Dave's benefit. So basically, by doing this, on printing this boss, this raised area on both sides here, that should make that extremely strong. Okay. I don't know that it's necessary. I don't know if they'll be on the final product, because the final bracket that I make, because there's a handful of considerations that I'm working through, kind of thing. So and I have actually been making progress on a YouTube video, and I wouldn't say I'm enjoying it, but I have made some changes, personalizations more or less to it. DaVinci Resolve is extremely flexible. At first I kind of hated to change a couple things because I didn't, you know, I wasn't sure I'd need the others later, kind of thing, and I was like, wait a second, I've edited videos for years with TrackX and never got too fancy, so I don't think I'm going to miss the stuff that I had to change. Oh, okay. That's part of the reason why I'm doing it in plastic first. I could make the changes and wait another 2.5 hours or so to print out another one, which I might. We'll see. But basically, this relief here on the back side isn't big enough to clear the spindle. Okay. On this, I'm going to have to increase these radius again here, and basically push this part here out a little bit, another 1/8 of an inch or so, just to make sure there's enough clearance. And like I said, the bosses, these raised areas, plateaus, may not stay on the final version, and if they don't, then it's, you know, it's not a issue. So yeah, see, it was hitting right in here. I'm putting this one back on. I went ahead and did a little clearance there with the Ryobi 4-volt rotary tool. Looks like I got enough clearance. This, I think this is going to tell me whether or not I need these, or even want these plateaus, these raised areas in here. What I got to thinking about was this boss being on the backside here isolates what's raised, and that means there's no chance of the rest of this coming in contact with anything. I have the boss set on here to be basically the same as that. Okay, so that way this can be flush and still keep the spacing. Okay, and that what that does is that will allow this even a hair more room to come back as this pad wears out. The tube won't move, but this part of the caliper will slide back and forth on the tube, and the head of the bolt is small enough that the caliper will go. See, I can push the tube all the way in there, so that's not a problem. What I'm more concerned with is with the raised boss coming all the way on there, I don't want it to come in contact with anything else, and I don't think that's really an issue. And I may opt to keep them, because I know I'm kind of vacillating here, but this is all about the thought process and the considerations for what I'm doing and why I'm going to come up with a, you know, final design. Okay, so my concern got to be with the tube coming out there and being put on here and threading in here really hard, tight, whether or not the aluminum would start to give, because that's not a machined flat surface, that's round, which means there's going to be a more of a contact point. You know, it's not going to be spread out. And so then I started looking at the option of putting a steel washer in here that I would have to clip on this side, you know. And then I was like, God, man, trying to put a washer in there, what a pain in the butt when you're trying to put it together and that stuff. If they were steel, I could get the washers, and the washers are about $2.50, $3 a piece. The specific, because I want them a specific thickness and that kind of stuff. So, but then I could just tack weld the washers on, and I could get the brackets laser cut. Okay, I'd still have to drill and tap and thread these, which really wouldn't be that big a deal. That would limit it to just the 3/8, and I'm sure the other company, their standoff here that they the tube they weld in here that's threaded, that's got to be 3/8 of an inch, roughly, which is still plenty. Anyway, I got to thinking about the washer, and then it dawned on me just a few minutes ago that the inserts that I want to put in the aluminum are time inserts, okay, and they have a flange on them. So instead of worrying about the washer, I could make the boss on the backside basically this size. I could make it a little bit bigger if I want, but then I can drill and tap and put the time insert in, and the time insert has a flange on it. So that flange has to get recessed in there in order to be flush. Well, in doing that, then I still end up with a hardened steel surface, flat surface, for that tube to hit up against. Okay? So that saves my problem with spacing and stuff like that. Or not with spacing, but with wanting to use the washer being on the aluminum and stuff like that. If I do them out of steel, I don't have to use the insert, because it'll just be a steel bolt going into a steel plate. No big deal. Yeah, and I don't know whether I would just put the washer on there and tack it on. It would help spread the load, but then again, it's not going to be threaded, so that's an extra, doing it this way with the tube, that's an extra 1/8 of an inch of threads, and I could actually run it out the backside further too. Looking at that, it's not going to go through the 3/8 anyway. It'll just poke out if I do that. And the thing is, the time inserts are super long. They're popular for some some Subaru head repair or something like that. It constantly strips threads. So it give me more time insert length in here. It would bring the height up, and I really don't think that it's an issue with hitting any of this. This is all pretty flat, but that's what I'm basically trying to double check right now. Part of why I was wanting to get rid of the plateaus, the high rises there, was because I thought, oh, I'm going to have to put the washer in there. Okay, and this may be a repeat. I don't know how it's going to turn out in editing yet, but anyway, if I go ahead and leave them at that thickness, I got to double check here. I'm pretty sure I'm centered right now, and the caliper's not really going to come this way much more because it's designed to go back that way as the pads wear. But I don't think I need to use the washer to create a hardened point under the tube because that time insert has a flange on it. And then so once it's set into the aluminum, the tube, the sleeve, will be forced up against the time insert, so it'll be steel on steel. That should fix the issue there. And I guess I'll have to decide at some point whether or not I don't really want to paint the aluminum. I could just leave it raw. I could send it off and get it anodized possibly. I might consider that. We'll see. That's still at least a few days down the road. Figure a week or two at least, because I still have to get everything set up with the mill and all that kind of stuff to actually machine these brackets. At least a 1/16 of an inch between the bracket and the back of the rotor. I could push the caliper back about another 1/16 of an inch. Still have some wiggle room here, but I can't wiggle that because it's the way it's snapped onto the caliper. Okay, but there is some space down in there. So now there's space there. The back pad has a little wiggle room too. So I think I'm going to go ahead and keep those risers on there. They're going to be chamfered, so any concern with clearance down in here, inside with the radius of the casting, I think that'll be negated by the fact that I'm going to, this will be chamfered, so when it sits inside the rotor, in the caliper there, there'll actually be a little bit more clearance. I think the design is good to go. I still got to change the clearance on the backside. I'll probably print another one, and then I'll take that final print and I'll take the other side off too maybe and go ahead and clear it, clean that stuff up, check it, just to make sure that it's good. Normally this has to get ground away and then it'll fit the stock steel rims, but I will check that too. I got to get the machining done on the rotors, get the studs put back in, and then I can check that more accurately. And I'll probably use the same on both front and back. Okay, now the Cadillac rotors are a little thicker. All that means is they'll absorb a little bit more heat. They'll also hold a little bit more heat, for fading and stuff like that. But this car's not going to get driven that hard. Any disc brake on here, even if this was a non-vented rotor, would still be a huge step up from drums. And I shouldn't say a huge step up. Drums have a ton of surface material to make contact with the shoes. Vice versa, the shoes have a ton of material to contact with the drum. So they'll stop pretty quick. The problem is you can't modulate them very well, okay? And when they get wet, then you're really kind of screwed with how long it takes them to work the water out. All right, this should be the last one. Still, I'm really pleased with how easily the supports came off. So we'll check this one real quick. Basically, I made it to where it should clear that better. Oh, yeah. Lots of clearance. I think that should have, I think you should be able to see the clearance there. Just threw a couple bolts in it. I guess I'm getting my hands dirty. I thought about putting a set of gloves on, but then I didn't. I've placed the McMaster car order for the bolts, the washers, and new grade 8 nuts. So they should be here Monday. Today is Thursday. Okay, so well, it came out the bottom. That kind of tells me that I'm not, I still have that clearance I wanted in there. Okay. I think that bracket is finished, more or less. I may do some design changes, cosmetic, that kind of thing, but